So we're going to look at various functions and talk about the domains of those functions. And the first one, I've already put the domain in there for you. For a linear function that is a line that goes through the coordinate plane, it is a first degree function that is similar to if we had a y equals, it would be y equals minus 3x plus 2, which would be slope-intercept form. And we know that the domain of that is going to be all real numbers. The second one, a quadratic, that also, any x value can be put into a quadratic. So the domain on a quadratic function, whether it opens up or down, is going to be negative infinity to positive infinity. But on the next three, we have examples of where domains need to be restricted. Some values have to be excluded. And the first one we have is it has a radical in it. It's actually what we call from our library of functions the square root function. And we know that with the square root function, the radicand or whatever expression is under the radical sign must be greater than or equal to 0, because if it is less than 0, we would not have real roots. We would have complex numbers. So in order to find that domain, we're going to take what's under our radical sign, and that's 6x minus 30, and make that greater than or equal to 0, and solve the inequality by adding 30 to both sides. So then we have 6x is greater than or equal to 0, and we will divide both sides by 6, so we have x is greater than, that's a 30, this is a 30 right here, 6x greater than or equal to 30. So then we have x is greater than 5. Now, we do not change the, and that's greater than or equal to 5. We do not change our inequality symbol on this type of problem because we divided by a positive 6. But remember, if you had had something that had a negative x in it, so that you were dividing by a negative number, so if this had been negative 3x plus 6 greater than or equal to 0, then we would have had negative 3x greater than or equal to negative 6, which would have given us x less than or equal to a positive 2. So remember, if you divide by a negative coefficient, you must flip your inequality symbol. It reverses your inequality symbol. So what this tells us, this is just an additional example here. So what we have here is our domain, all x such that x is greater than or equal to 5. In interval notation, it would be, so it's all x's that are greater than or equal to. So it's going to start with 5. That's where it begins. We'll have a square bracket there because it can equal 5. That would give us 0. Square root of 0 is 0. Then it goes on to positive infinity. The next one we have is a logarithmic function, and even though we didn't study this until later in the semester, I thought it was important that we put all of these different types of functions together and consider domains in all of the different contexts. So a logarithm, we know that when we're looking at a log, the argument cannot be negative. So it also cannot be 0. So whereas with the square root, to find the domain, you're going to set it greater than or equal to 0. In the logarithmic function, we're going to take the argument and just make it greater than 0. So we'll have our argument here is whatever the log is being taken of. So we have x minus 5 is greater than 0, or x is strictly greater than a positive 5. So our domain on the logarithmic function will be a parenthesis because the 5 is not included. You can't take the log of 0, and that will go to infinity. And then lastly, we have a rational function. And we know that there are exclusions that go along with a rational function because we cannot have no 0 in the denominator. Never ever. Make yourself a big note about that. And what we're going to do here, and I saw this was problematic on the Unit 4 test or the Unit 3 test for some, we're going to find where will this be 0 and then exclude those values. So let's take our x minus 5, set that equal to 0. So that means when x is 5, x minus 5 is 0. But we're not looking for where it equals 0. We're looking for the values that we need to exclude. Make sure you exclude that value. So if we think about a number line, there's our 5, there's a 6, and there's a 4. It is everything up to the 5, but then there's a hole and everything beyond the 5. I'll scoot that over just a little so you can see. So in interval notation, we're going to go, it's everything less than 5. So we will have from negative infinity to the 5, and an open interval, then a union, open the interval again, and pick back up at 5 on the other side of it to positive infinity. Now often you'll be asked to give, for rational expressions especially, you'll be asked to give the exclusions. What has to be excluded from the domain? And that would be set builder notation, x, all x such that x is not equal to 5. And that would be your domain on that one.